In today's class, we'll discuss about one of the retrieval utilities we have. So in previous class, we have discussed about one of the retrieval utilities that is relevance feedback utility. Basically, this utility uh, models helps the major information retrieval models to improve their performances. So we have seen that in the previous class. So I will not speak about this again. So we were talking about this relevance feedback strategy or model, which helps to increase the performance of the major models. Okay, so we have seen how this relevance feedback model works. So let me quickly rewind this topic. So what happens is, um, initially a query, the main concept of this model is to update the query until you get a totally refined query. So what we do is, first we ask a query, and depending on that query, we will get some documents, and the user can choose from the retrieved documents which documents are relevant and which documents are irrelevant. So based on the what we say, based on the feedback from the user, the query, the old query is updated and the new query is generated, and we use that new query and we execute that query, and we will get another set of documents, and again user chooses, or user checks which are the relevant documents and which are not relevant document. So by doing this, each and every time a query is executed, from the relevant documents, the terms which have more weight, or the terms which have more frequency, are added to the query, and the query is updated. Now this process is continued until the user gets his desired output or document, or the user thinks that the query is well refined. Okay, so this is the relevance feedback model, and we will now see how this relevance feedback model will use the vector space model to retrieve the relevant documents. Okay, so this utility model, which we now call as a relevance feedback model, is joined with the vector space model, which is a information retrieval model. So combinedly, we will use these two, and we will see how these two retrieves the relevant documents. So this model was first what we say presented by Rocchio. He is the person who used this relevance feedback model with the vector space model. So you know that these two are different. Vector space model is different, and its strategy of retrieving the data is different, and relevance feedback is its strategy is different. So what Rocchio did is, he combined these two models together, and he tried to retrieve the relevant document based on his new approach. Okay, now let's see. I hope you know the how vector space model works. Yeah, if you know how vector space model works, then you can easily understand this combination of relevant feedback and this vector space model. Okay, let's continue the concept. So Rocchio's approach used the vector space model to rank documents. The query is represented by a vector Q. Each document is represented by a vector di, and a measure of relevance between the query and the document vector is computed as SC of Q comma di. SC means similarity coefficient. So you know that each and every term, or each and every document each and every document in the space model is treated as a vector. Vector is nothing but a dot or a point in a vector space. So each and every term in the query and each and every document are represented as vectors in a vector space, and the similarity coefficient between the query terms and the documents, or query vectors and the document vectors, are measured. So in order to measure the similarity coefficient, we can use the many techniques. But here in the previous topic, we have used cosine similarity. That means finding the angle between the two vectors, okay, and deciding whether the two vectors are similar or not. So here what we are doing is we are simply treating a query term and the document, or query and the document, as 2 points, and deciding whether the 2 points are closer to each other or not, or similar to each other or not. So for this purpose we are using a technique called cosine similarity coefficient, which generally measures the angle between the two vectors and decides the two vectors are closer to each other, or whether the two vectors are similar or not. So that is how vector space model works. So here um, we will see the next point. So similarity coefficient is computed as the cosine of the angle between the two vectors. Just now I have explained this one. The basic assumption is that the user has issued a query queue and retrieved a set of documents. The user is then asked whether or not the documents are relevant. Now we are talking about relevance feedback. So the first step in relevance feedback model is to ask a query. So we are asking a query queue, and when we ask the query queue, based on that query, some documents are retrieved. A set of documents are retrieved. Now the user comes into action, and the user decides which from the documents which are retrieved, which documents are relevant and which documents are not relevant. So this can be done in two ways. One is manually and other is automatically. Hello, can you hear me?
Yes, sir.
Okay. So when the documents are retrieved, so the user can manually select by checking the documents. He can understand that, okay, this is the document, or these are the documents which I am looking for. So and these are the documents which I don't want. So he will filter the relevant documents and the non-relevant documents, isn't it? So this is the manual way. The automatic way is without user intervention, by deciding the top 5 documents are relevant, and by assuming the top 5 documents are relevant, and the remaining documents are relevant. But here we are using the, or we are taking the help of the user, and we are deciding whether the document is relevant or not. This is the first step in relevance feedback model. So after the user decides that these are the relevant documents, now what we'll do is we will convert that relevant documents into vectors, okay, and the non-relevant documents also into vectors. So that is the second step. After the user responds, the set R contains n1 relevant document vectors, and the set S contains the n2 non-relevant document vectors. Now, simply what happened here is we have two sets here, set R and set S. Set R contains the relevant document vectors. Now the documents are converted into vectors. I told you how to convert a document into a vector when we were talking about vector space. So I will not talk about that again, but simply understand that the documents are converted into vectors, and the vectors are divided into two. One is R and S. R contains the relevant vectors and S contains the non-relevant vectors, or vectors which belongs to the non-relevant documents. Now we have three things here. One is the old query, two is the relevant document vectors, and which is R, and three is the non-relevant document vectors, which is S. So we have Q, we have R, we have S. Using these three, we will calculate, or we will come to a, we will generate a new query. We can call it as a Q1. So Q was the old query. We can generate a new query by simply considering the old query and the set of relevant document vectors and a set of non-relevant document vectors. Let's see how we can do that. Going to the next slide, you can see a formula here which simply tells us how to generate the new query, which is represented as Q dash or Q complement, whatever. So Q dash is nothing but a new query which we are looking for, and this new query can be generated using this formula. So which have Q, which is nothing but the old query, and R, which is nothing but the relevant document vectors, and S, the non-relevant document vectors. So what we are doing here in this formula, let's see. So Rockio builds the new query Q dash from the old query Q using the given equation below. Now, so in general, if I try to explain this, so what we are doing is we are adding the relevant document vectors to the old query. You can see Q plus summation of Ri are nothing but the individual vectors in the what is a relevant set in that set. So we are adding the relevant vectors to the old query, and we are subtracting the non-relevant vectors from these two minus summation of Si. So n1 is nothing but the total number of vectors, and n2 is nothing but total number of relevant vectors. N2 is nothing but total number of non-relevant vectors, and Ri and Si represents the individual terms in the vectors. Yeah, Harish Reddy, what happened? So what we are doing is we are adding the relevant vectors to the old query, and we are subtracting the non-relevant vectors from the old query. So the document vectors from the relevant documents are added to the initial query vector, and the vectors from the non-relevant documents are subtracted. Simple. So by doing this, the actual idea behind this is that we are trying to add more weight to the terms which are in the query, which are relevant to the document. And we are trying to decrease the weight of the terms in the query which are not relevant. Okay. So if we read these lines one by one, the idea is that the relevant documents have terms matching those in the original query. Okay. So um, obviously the relevant documents will have the terms which are there in the query, isn't it? And the non-relevant documents which are retrieved may not have the terms which are relevant to the query. So what will happen is the weights corresponding to these terms are increased by adding the relevant document vector. So suppose if I am looking for a query cat dog, so the my query contains the term cat and dog, and the relevant document also contains the term cat and dog, so number of times. So what I will do is I will increase the weight of that cat and dog, right? So that I will increase the importance or the influence of that term, right? So by adding that to the old query, so that is what it is mentioning here. The weights of the corresponding to these terms are increased by adding the relevant document vector. So the third point is terms in the query that are in the non-relevant documents have their weights decreased. Suppose a we have some word like horse or frog in our query, and those terms are appeared in the non-relevant documents. So the terms which appeared in the non-relevant document, their weight is decreased. That means we are decreasing the importance of the words, and we are increasing the importance of the words which are there in the relevant documents. So we are increasing at one point and we are decreasing at another point. We are increasing the weight of the relevant terms and we are decreasing the points of the irrelevant terms, or the terms which appear in the non-relevant documents. So that is the thing we are doing. So when we continue this process, so at last what will happen is all the non-relevant terms will be ignored or will be deleted, and all the terms or all the relevant terms will remain in the query. All the non-relevant terms will be removed, and only the relevant terms will be there in the query. And when your query has only the important terms or the relevant terms, then there is a high chance that you could get a document which you are looking for. Okay, so by using this simple formula, we are generating the new queries. Let's consider it as Q1. So we are in this phase, it is Q1, and when we use this Q1, we get a new documents. We'll generate Q2, and we use that Q2 to generate new documents, and we generate Q3. So we'll continue this step until we get the required document. Okay. Also, terms that are not in the original query are now added to the original query. Okay. So while you are adding the weights of the terms which are there in the query, you may notice that some terms in the relevant documents and which are not there in the query. So you may notice that terms um, are appearing more times. So what will do? You'll think that okay, this term may be important. So what will do? You will add the term from the relevant document to the query. So actually the term is not there in the query, but you are adding the term in the queries because the term appears more times or appearing frequently. So you could add, you can add that term to the query. So here you are doing two things. You are increasing the weight of the term which are already there in the query, and you are adding the new terms to the query which are not there in the query from the relevant documents. Okay, and coming to the non-relevant documents, the terms which are there in the non-relevant documents and which are there in the query, you are simply decreasing their importance or decreasing their weight, so that slowly you are simply deleting that words from the query. So ultimately you will left with relevant terms in your query, and you can use that query to retrieve your document. So this is how the relevance feedback model and the vector space model are combinedly used to retrieve the documents. So we have used the procedure of relevance model in the form of vector space model, and we have achieved the goal here. I hope you understood this one. If you have any doubts, you can